Welcome to the FarmBits podcast.
FarmBits is proudly produced by the Nebraska Digital Agriculture Team and hosted by students at the University of Nebraska.
The FarmBits podcast comes to you each week to discuss the trends, the realities, and the value of digital agriculture.
Through interviews with experts, producers, and innovators from across the agriculture industry, we hope that you step away from each episode with new practical knowledge of digital agriculture technology. Hello, FarmBits followers, and welcome to another episode of the FarmBits podcast. I'm Taylor Cross.
And I'm José Cesario, and we are glad to have you with us as we continue learning about the topic of precision land management.
On this episode, we welcome Todd Martin from EarthOptics, a new company based out of Arlington, Virginia.
In this episode, we learn more about their efforts in soil management and carbon mapping to increase the data available to users and growers.
EarthOptics has a very innovative handle on precision tillage within the agriculture industry. And with that background, let's dive right into learning about EarthOptics with Todd.
So my name is Todd Martin. I currently serve as the Chief Commercial Officer for EarthOptics. I've been in agriculture, I guess, all of my life, but I'll count professional agriculture for the last 30 years. I joined Ciba Geigy in 1990, and of course, Ciba became Novartis, which ultimately became Syngenta. And I spent 25 years with that organization in a whole host of roles, from crop protection chemical sales through seed sales to biotech development to managing globally dispersed teams and intellectual property and key account management. It was an exceptional career there. It was a really very strong organization, continues to this day. About 6 years ago, I hung out a consulting shingle and was honored to be asked to lead the Independent Professional Seed Association, which is a trade association in the 25 states, predominantly in the Corn Belt, that's made up of 125 independently owned seed producers that have about a quarter of the corn and soybean market today. And they asked me to sit in as their CEO and help them through that organization, which I still do today. And a bunch of really great people. I've always said agriculture people are the best in the world. And I'll tell you what, those seed producers, when you get them together, they're just an unbelievable bunch of great people. So it's good to work with. About 2018, and this is the part that gets a little bit deep into EarthOptics. I had a good friend who was at the AgTech Accelerator in Raleigh, North Carolina, named John Dombrowski. He and I were talking about a couple of different ideas, and he brought a concept to me that said, hey, Todd, I just had something come across my desk talking about ground penetrating radar and utilizing it in the agriculture space. What do you think? Do you think that has any value? And so through a couple of different conversations, decided that we'd start looking into it, because when you look at it, ground penetrating radar is one of those really exciting things. It was originally, came up with through the military industrial complex. DARPA came in with ground penetrating radar and started using it to identify IEDs in war zones to help protect our troops. So, you get an opportunity to work with that type of technology. It's really pretty cool. And we also had another gentleman, John Anderson, that has had a long history in the agriculture industry, who was part of our three-man founder team. And we did a lot of work throughout 2018 looking at that technology and some other technologies, and had some meetings at MIT. And ultimately, in December of 2018, we got our initial round of funding to give birth to, at that time, a company called Ground Truth Ag. And that has ultimately become EarthOptics. So we were there at the beginning to actually give birth, if you will, to the organization in December 2018. Shortly thereafter, we went through proof of concepts. We hired a gentleman as a scientific advisor named Lars Derud, and Lars, in the latter part of 2019, we selected as our CEO to help us go forward. And so here we are today, and we are moving into the market with our GroundOwl device that is made up of sensors of electromagnetic induction and ground penetrating radar. And it's some pretty exciting times.
Well, that's a pretty impressive path, Todd. Would you mind providing us an overview about the EarthOptics?
Well, so EarthOptics, as we have come to be known now, what we are doing is we are working with agriculture service provider specifically to work with farmers. And, our original package of product that we were coming to, we want to be a company that basically helps evolve the soil analytics system. If you look at what's going on in soil analytics right now, we're taking soil samples and we're putting them in boxes and we're shipping them to labs. Labs are running tests, and maybe the tests are a little bit newer than they used to be, but this is the same way we've done it for 80 years. And what we'd like to do at EarthOptics is move that into the 21st century, utilizing all the great technology that we now have at our hands. I mean, we've got technology that's on the Mars rover that is helping to identify what's happening on, what the soil makeup of Mars is. And this is some of the things that we want to be able to bring back and put at the disposal for use of the American farmer and farmers throughout the world. So that's kind of our overarching vision. Now, along the way, our first path to market on our first product is through our GroundOwl, and that's with our product called TillMapper. And what we do is with ground penetrating radar and EMI, we can go through a field on, with our GroundOwl on a side-by-side or now on a tractor, and we can measure the compaction in a field. Now, I always say that's not a super sexy thing to do, is to talk about soil compaction. But soil compaction and bulk density have a lot of effect on how plants grow and how well plants grow. Every farmer out there knows he's got some problems with soil compaction. He usually infers them looking at his yield maps and sees, okay, well, over in this section of the field, my yields aren't great. I've got some standing water. That's an area that I know that I'm turning my combines in the fall and turning equipment around. And so they know compaction affects them, but they've never had a really great measurement to be able to say, yep, this is what it is. And, most soil scientists right now would tell you that about a compaction pressure of about 250 PSI starts inhibiting the roots of your crops. So your crops don't grow as well. So what we can actually do is create a 3D map of the soil all the way down to 3 feet. And we can tell you what that pressure is centimeter by centimeter all the way down. So you can literally see where you need to till and how much you need to till. Now, that starts getting into some exciting technology. There are equipment companies out there that have been manufacturing variable tillers, variable depth tillers for a while, and they don't have a good way to feed exactly that information into that tiller to make maximum use out of it. At EarthOptics, we can provide that level of information. But even more importantly, for a farmer that doesn't have that tiller, we give him a view of where in his field he actually needs to till. And we can say, you need to deep till here, but you don't need to touch the rest of this field. And so even if he doesn't have that, he's got an ability to manually go and choose exactly where to till and how deep to till. The result of that is immediate to a farmer because he's saving fuel, he's saving hours on his tractor. When you're pulling a 2-foot knife rig through a field and you've got that thing sunk very low, that takes a lot of tractor power. So that's real savings. We're talking between $20 and $40 an acre. But even beyond that, there is a labor savings that comes into that as well. And then comes all the stuff everybody wants to talk about today. It's more sustainable in real terms. We talk about sustainability in ag. And of course, I'm one of the people that believes that every farmer out there is a true environmentalist because look, they understand the importance of the land, maintaining the land, getting the most production out of it, making sure it's there for kids, for grandkids. And most of the farmers are also hunters and fishermen. And so they really have a touch with nature and the land like very few people in America are blessed to be able to have. So when we start talking about things that farmers can do that is more sustainable and works better, and so many times it's just big picture terms. At EarthOptics, one of our core concepts is we want to measure everything and we want to give things out to the farmer that are true and actionable. So give them some real things that they can do. And by knowing where they need to till and how deep they need to till, we're giving them real information to save them money, but also it lends right into being more sustainable.
So you talked about GroundOwl and the TillMapper. I recently saw where, I think back in March, y'all were awarded the AGCO Innovation Challenge. So do you just want to talk a little bit about that and kind of more in depth on the TillMapper and the prescription test that y'all have generated?
Well, so it's interesting. I mean, the AGCO Equipment Challenge was something that our technical team got involved in, and Lars Derud, our CEO, really drove forward, and it was all about that tillage piece and what we could do, and the fact that it is such an innovative thing. So we were very excited to win it. It's prestigious, and I think it recognizes exactly how important that compaction view and tillage view really is. So kudos to our technical team for being able to establish that and go through that entire process. I think from a standpoint of prescriptive, one thing that I want to make sure is very clear here. It is our approach to business. And one of the things that we like to say is that at EarthOptics, we want to be the guys that are measuring and giving information. So we're really about the democracy of information, getting it out there to people that can really make a difference. But I can tell you from my experience in agriculture over the course of my career that one thing that I respect probably above all else is that farmers are inherently smart people because they deal with everything out there under the sun, and they develop really trusted relationships with a few people that can give them tremendous advice. And those are people that are local agronomists in their areas, or a lot of people have their own consultants that are sitting out there, so they grab those. And then there are also some really great service people at some of the co-ops that they're going to do business with, or the seed companies that they do business with. So here's what we do at EarthOptics. We're not going to try and go do everything on a farmer's field and come back and say, here's the prescription that you should do, just in a box based solely on our information. What we want to do instead is actually give that information and teach the service providers, whether it's an agronomist, a consultant, maybe it is somebody the farmer has on staff in a large farm situation, or working with the co-ops or seed companies or other providers. Those people that the farmer relies on for information, what we want to do is empower all of them, because they're going to walk onto the farm. They're going to know that farm from a historical standpoint. They're going to take the data that we give, and although we know it's very actionable, they're going to look at all the other things that they do on that farm. They're going to understand that individual farmer's objectives more than anybody else. So they're going to be able to take that information and really utilize it in a way that best benefits the farmer. That way, and I want to differentiate it. We're not a company that's just trying to go all in one size fits all. Here's the prescription based on the information, because we know, even though we can tell you exactly where to till and when to till, we also know that each individual farmer has different objectives, and they need to rely on the advice that they're very comfortable with, and we're giving them new data points. So now they have new information to make better decisions.
And you talked about these technologies that your company has given for the co-ops and all the agronomists from that point. Could you give me a description of these technologies and the products that it offers, like, and also who are your main customers?
Sure. So, of course, right now we have one sensor product that contains a couple of sensors. So our GroundOwl product, trying to describe this, we've internally called it a couple of different things. The one we're currently deploying, we kind of call the hammerhead shark design. It's a design that fits on the front of a side-by-side or tractor and has a big horizontal piece that goes out. And that contains both a ground penetrating radar, and we have a license through MIT for localized ground penetrating radar, which is the second thing, an electromagnetic induction unit. And what we do there is you attach it to this device that goes, to this side-by-side or tractor, goes across the field. And you just run across the field and take all the sensor readings. And that logs back into one of our two products that we work with farmers and, service providers on, which is our TillMapper today, as I've described, and our CMapper. So both of those products generate a lot of information, but we display it in digital 3D formats. It all goes into the cloud. So it's not real time, but it's near real time. Our limitation there is really how quick you can run it across the field, and then you can communicate via internet up. If you've got great cell service, it uploads at 5G speeds. If you don't, and you don't have any cell service, like a few of the fields we've been in, it uploads when you get back within cell service and internet service. But the products that the farmers actually get, that's how we collect the data. The products that the farmers actually get, 3D maps that give layer information like we described with the TillMapper, that actually gives you the ability to look at the pounds per square inch of pressure down to, about 30 centimeters, and at a centimeter by centimeter level. And then also we have the CMapper product that gives us that same ability to look at the carbon sequestration in the soil. And we haven't talked a lot about that one, and I'm sure we will, because carbon sequestration is on everybody's mind as we look at climate smart agriculture and forestry from the USDA, and we talk about greenhouse gases, and we talk about carbon and how we can be more environmentally friendly. The benefit that EarthOptics is bringing to the table is we're cutting a middle ground on carbon between the trusted old way of collecting a literal ton of soil samples and doing carbon testing to get a great picture of what your current carbon level is, which is slow and expensive, and then trying to go totally an estimation route with remote sensing, looking at satellite imagery and common practices and saying, no matter how nice they put it, we guess you have this much carbon in your soil. And EarthOptics is measuring the soil efficiently and effectively and coming out with a real verifiable measurement. So all of a sudden, inexpensively, we're able to measure carbon very quickly and really give real numbers to farmers to help facilitate the carbon economy. I do need to add one more thing, and I've neglected to point this out, because I've talked about the GroundOwl and what that sensor pack looks like, and how we run it across the field, and we can really run it pretty fast. I know that we did some speed tests, and I got to be the driver of the side-by-side, which was really fun, and we were running it 35 miles an hour across the field, and our data was just as good as when we were running 5 miles an hour, and we did that back and forth, and we pushed it a little faster, and basically we can take scans as fast as field conditions will allow. You really got to know your field, though, because finding a water ditch in the middle of a field that you didn't know was there at 30 miles an hour can be really exciting, and not in the best way. But anyway, one of the things that I neglected to mention is the thing that sets us apart, and I think this is really key, is our ability to use artificial intelligence and machine learning within everything that we do. Because what that does is it gives us an opportunity to look at correlations around the entire picture of soil variability that we're taking. And that is what differentiates us from regular testing and basic analytics that other people are running, because as we continue to feed the AI more, get the machine learning going, every data point it collects, every acre it digests, everything that we give it, it literally gets smarter and can really look into the soil deeper and give us better information. So one of the things that I see in the future is getting to a piece at EarthOptics where we're doing totally touchless soil testing. Now, we're not there yet, but I can tell you, when we drive into a field today, if we're doing carbon, we're going to still take some carbon samples, because we're still teaching the AI. And at the same time, we want to validate that we're doing the correct thing. We want to make sure that we're new. We still want to verify our information. So we still take samples, but we take 2/3 less samples. We'll take 1/3 of the samples that you would normally do under totally trying to measure carbon. So we can take 1/3 of the samples and get the better information, quite frankly, than we could if you sampled the entire field. So that's exciting to me. And knowing that as we get smarter, that sample curve is driving more towards zero. Now, my good friend Lars Derud, our CEO, who is a space scientist, he reminds me all the time. He's got the big PhD behind his name, and I do not have that. Lars knows science. He spent a large part of his career building satellites and working with remote sensing. So he knows those systems and know what they can do and what they can't do. Lars keeps telling me that, hey, Todd, we probably won't ever get to zero, but we're going to drive the number really low on the type of samples that we need to take. But I'm still going to say that's my objective. I'd love to see it that way. I think our technology should get us there at some point. And it's all about that machine learning and being able to continually feed the AI and make sure that it continues to grow smarter.
Yeah, that's really interesting and a good objective and goal. Super, super innovative. How often is this data collected? And not only how often, but are growers collecting it? Do y'all have field technicians? Is that like a service y'all provide?
So Taylor, that's a really good question. Currently, we have 6 teams deployed of our internal teams. As we're growing that number by another 10 over the next 45 days, so that they're out there doing the field work. Now, as we start moving forward, and of course, our equipment is out there and our GroundOwls, we're continuing to manufacture those. And, as you would expect, the first ones that come out, our prototypes, are incredibly expensive. But as we continue to manufacture more, that cost drives down really hard. So we're going to come to a point, I hope within the next 12 months, where these units are very affordable for a farmer if he wants to buy them and do it and deploy a unit himself. But even more importantly, they're going to be incredibly economical for a consultant or agronomist who wants to be in that side of the business. And so many of those people are already doing soil sampling work. We're just going to empower them to go and do more acres, do it more efficiently, and do it in less time. So it could be an add-on to their services that they already do. And, currently for our TillMapper, we're looking at prices around $3 an acre. And for our CMapper, about the same thing, which is much cheaper than they could get anything on an elemental analysis, they being the farmer, through any laboratories. So we're looking to, currently it's internal. We're looking to expand that out so that, consultants and agronomists can have an opportunity to work with that. Farmers may, depending on their size. I think right now, if I were going to be a farmer to judge it, I'd probably look at, if I had about 8,000 acres, I could probably justify it. But I think the guys that can really justify it, guys and girls that can really justify it, are those that are already doing multiple advising across farms. That's where they can really make it work for them well. And I think the nice part about it is it's a new revenue stream for them, so it helps enhance some of that revenue. Now, you also asked the thing about how often do you do it? I mean, really and truly, from a tillage standpoint and from a carbon standpoint, we're going to do something a little bit more unusual. A lot of the carbon credit programs now run about 5 to 7 years. We're going to actually subscribe that we're looking at some things that we want to do year over year. So we do think that, doing an annual scan of carbon is going to be one of the things that we want to do. Doing an annual scan of tillage, if you've done one full scan in a year, you may want to come back and do another just to see what has changed until you really get an idea of where that compaction is going to move and what the effect year on year is going to be, and with certain environmental conditions. But I would say annual scan is at most you're going to be doing there. And it may be a scan every year or two. We're looking at introducing a very new concept into carbon called the Soil Carbon Project. That will take an annual scan, because we will look at carbon sequestration year over year with the farmer. And as that carbon sequestered increases, which means, of course, carbon dioxide in the atmosphere is minimized and decreases, we are looking to help farmers find a food partner that will actually pay a premium for that carbon crop. And we call it a carbon crop because, it's reducing carbon out of the atmosphere, sequestering more carbon, and it's measured and verified. And through the Soil Carbon Project, we want to have a nice little thing out there working with the food companies where they can put an emblem of the Soil Carbon Project on their food. And we absolutely know the consumers can drive demand when they think things are important. We saw that with Project Non-GMO. And as we become more familiar with everything that is affecting, carbon in the atmosphere and trying to reduce our carbon footprint, I think this is one way to give consumers a choice on products. And the exciting part about it for me is it's an opportunity for us to help a farmer enhance what he already does by selling crops at a premium to what he can get as just a regular basis. Seen several of these opportunities start going around organic and non-GMO, and while they don't work for every farmer, they don't fit every farmer. The farmers that do see a lot of benefit. So I think that that's a real opportunity that we're going to work and help present to the farmer directly.
Yeah, real quickly, can you value the importance maybe to a grower specifically on like why is it so important for them to have access to these carbon maps?
Well, I think that one of the things is I'm always one of these people that believes information is power, and the more information you have, the better off that you are. The problem that I see is over the course of the last, let's just call it 12 years, since we've really gotten involved in precision agriculture, it's not uncommon to go to a farmer's office, wherever he is, see the guy open up a drawer and it'd be full of USB flash drives and hard drives. And it's all his yield data and weather data and satellite mapping and just all of this data. And, he's going to probably look at a couple of things. He's going to look at his yield maps because he wants to know in the field where he's getting the best yield and where he's not. And that's important information to him. He's going to look at his soil maps at the beginning of the year because he's looking at his fertilization. And then a lot of it gets to be noise. And, it's nice information to have, but is it really helping me make a decision? Fully believe that as we look at the TillMapper product, that's going to help him make a decision. It's going to help him save money, help him facilitate getting in the carbon economy if he'd like to be able to do that. Likewise with the C-Mapper and the carbon maps that he can look at. Those are going to be paramount to him being able to participate in something like the Soil Carbon Project, where we can help him develop a premium market for his crop, where he has maximized carbon in the soil. I think the other piece of it is that they're going to give him real value year over year if he enters the carbon market for selling carbon credits. One thing that we know today is the carbon market in the United States, 1%, 1% of farmers, agriculture lands participate in the carbon market, 1%. And 46% of the land in the U.S. is agriculture based in some way or another. So holy smokes, what a disconnect on being able to participate in that market. Well, why don't they do it? One thing is it's hard as heck to understand. It's not just easy to get into. Secondly, for me, somebody's telling me I got to do something in the next 5 to 7 years. And then thirdly, yes, I can sell carbon credits, and I've got programs with the USDA that they're changing now because the USDA is really focused on climate smart agriculture and carbon farming, if you will. But I've got things that they just don't work out economically. So let's think about this. 7-year program, having a hard time understanding that. I need to, in a lot of ways, look at my farming practices. Okay, I need to grow cover crops. That may cost me as much as $40 an acre to put in, but I can get a $15 an acre piece back from the USDA. So I'm going to spend $30 an acre to do that. And then I need to try and till less over here. I don't have a real way to manage it. The programs are based on things that I do. I need to try and reduce nitrogen. There's some new pieces on nitrogen fixation, and holy smokes, at the end of the day, I really don't know what I'm going to get. I'm jumping through every hoop under the sun to do things, and I don't really see what I'm getting. That's the difference that we're going to give them. We're going to tell them immediately, here's your baseline. This is how many tons of carbon you have sequestered in your soil. A year from now, we're going to come back and say, this is how many tons of carbon you have sequestered in your soil. This is what you have that carbon is worth to sell. And when you've got all kinds of companies that are pledging to be carbon neutral by 2030. The carbon economy is going to have to open up. When you got a company like any airline, American or Delta, that is going to move into the carbon economy, and they're literally going to spend a few $1 billion buying carbon offsets. If I'm the CEO of one of those companies, I'm going to want to make darn sure I know what I'm buying before I spend $1 billion, because I don't want somebody to come back and say, oh, guess what? Yeah, this carbon you bought for this much money really isn't enough. And we measured it. And yeah, no, I want to know what I'm buying. If it's a brick, I want to buy a brick. So, that's where I see the real value to a farmer at having the information and a baseline information on carbon on his farm, and then knowing what he's doing and what the real impact is. And I mean, let's face it, one of the significant things that we have to understand is what we are doing. Is it really making a difference for us? I mean, the worst thing that we could do is start running down the road of a carbon economy and saying, we're doing all this work and we're doing all this stuff, and there is zero impact, and there's no carbon dioxide reduced in the atmosphere, and there's no additional carbon sequestered in the soil. Boy, that's a bad day, and that's bad on us. Mm-hmm. So measuring accurately and being able to validate what's actually happening is urgently important to be able to make this work properly. Because yes, it is about economics for a farmer, but in the long term, it's about, cleaner air for all of us. So I just believe that we have to know what the measurements are, and that's the value of what EarthOptics brings.
Is there any specific cases that you want to share with us that EarthOptics really made a difference in someone's operation? If you're allowed to share a story like that with us.
Well, I can think of one in particular, and keep in mind, we're still very young, so we're really getting started. And, if we look at a year ago, we're deploying our very first prototype units on side-by-sides and trying to figure out okay, do we have to go at 5 miles an hour across this field, or can we go at 50 miles an hour across the field? And are we going to really be able to see that drain pipe down there or not? And, so early in the process, and I think this was that confirmation aha moment, we got this, is we're running on a farmer friend of mine. And he's got 11,000 acres of land, and he is one of these guys that deep tills all the time. I mean, he not every year, but it's part of the process of what he does. And he is an incredibly efficient and great farmer. If you're farming 11,000 acres, you got to be doing something right, or else you're going to lose your shirt really quick. And this guy is one of the real innovators, and he really looks at everything for dollars and cents. And we were running his acres, and honestly, giving him back information, and he was running a tiller across, and we're coming in and saying, you got it here. Here's where your problems are. You don't need to touch this field, which is the next field he's going to. And he says, yeah, I haven't touched that field in 3 years. I have to go there. No, this is what it's telling us. Yeah, I can't buy it. Okay, let's back up. Here's what it's telling us over here. Yep, I'm over there. Here's what it's telling us right beside that. Got it. Here's what it's telling us here. You really don't think I need to till that field? You don't need to. All right, but if my yield's down, I'm really going to be hacked. Well, that was last fall. He didn't till the field. His yield was fantastic. We're going to have to prove to a lot of people that this is real stuff from time to time. I mean, I think one of the challenges we always have in ag is when somebody's doing something right, it's hard to get them to change, because, there's that old adage, if it ain't broke, don't fix it. And how many times we tried to fix something made it worse. So, when we can get down into a specific situation and we've got a solid farmer that we can work with and say, hey, look, trust us, this is why, and we don't need to go here. And then he sees the real difference. Yeah, he's a believer. And that's where you necessitate a significant change. So that's really kind of a small story, Taylor, of one incident of a year ago, but it's a year over year story. What we did last fall, farm to crop, got results. We know it works. We know it's right. And we could tell looking at the doggone radar put out in the maps that, wow, you don't need to touch this field. It's fine. So, that's the type of level of difference that I know that we can put in, for everybody that wants to work with us at EarthOptics.
It's amazing, Todd. Why are you most excited about the future of the EarthOptics?
Well, it's really funny because I'll tell you a couple of things that have happened. So as it went through, as I told you, kind of this whole idea that we could change the landscape of soil testing and give farmers more information better, faster, more efficiently, and actually saving some money along the way too. And that's always a good day. If you can do something better and faster and cheaper, yeah, I kind of like to look at those type things. May not believe them at first, but if I can prove it to myself, let's go. And then we stumbled on carbon. Carbon really was not even on our projections for the future, but we always look at sometimes, I had a old friend that used to tell me luck is preparation meets opportunity. Well, we were prepared and the carbon opportunity came. But let's take carbon out of the equation for a minute. If we have a situation where we're approaching a farmer about soil compaction, we're still having him be more sustainable regardless of the carbon. But what is the future on EarthOptics? Well, next year, we're going to introduce our moisture mapper and our nutrient mapper products. And those are exactly what they say. We've had to learn more about soil moisture levels in particular points across because we've been educating our AI because moisture directly affects soil conductivity, which directly affects our readings with regards to compaction and carbon. So we've learned a lot of really cool things about moisture. So we're going to be able to deploy that product into farmers. But the next one is the one that I've been looking at and is really exciting. And those where we're combining a couple of more sensors into our GroundOwl unit to help us look at elemental products. So we're going to be looking really at NP and K and the entire line of micronutrients out there. And that's the next step. That's where we can say that basically when we run into a field, we're going to scan you for all of your soil elements and be able to give the fertilization recommendations and be able to have the units and say, this is where you are with regards to all the elements in your soil and what's available. And I think that's going to be a really nice next step as we go forward to be able to take that in, and that does change again, the dynamics of what's happening with regards to soils. We're seeing companies out there now, they're doing testing and they're doing microbiome studies and pieces like that. And I got to tell you, they likely will continue to do those. But if we can get down to where we can scan with compaction and we know compaction and moisture, and we can also give the elementals, it changes the direction of what's going on. And then there's a really exciting product that we're just working on from a development, and it's called Pest Mapper. And this is where we're really looking into how we can map out pests in the soil like nematodes. Now, that's really early stage and we're not there yet, but that is absolutely something on the horizon that is exciting. So we still got to get to proof of concept. We've done a few tests. We've got a lot more work to do. But I mean, as we look out and we look at the technologies we're deploying, we're seeing lots of opportunities to get really excited about products that we can offer in the future.
Before we wrap up here with two more little generic questions, is there anything that we didn't talk about today that you want to share with our listeners specifically?
By and large, I got to give y'all a compliment. Y'all certainly did your homework around EarthOptics and, what I think are the really important questions. So I can't think of a whole lot else that we have not covered. We're really excited about where we are today and the people that we've been able to work with so far. And I really hope that from your listener standpoint, they'll pick up the phone and or drop us an email and say, hey, look, can you come out here and talk to me about this? And what can we do to work together from that perspective? I will tell you, we're doing a lot of work in the upper Midwest. And, I know the winter's coming. We're going to keep on working until snow falls. And then we'll be moving down south and working into a lot of the southern states and continuing through December and January.
That's great, Todd. So, and where can our listeners go to learn more if they are interested in the EarthOptics?
The easiest thing that they can do is go to earthoptics.com and take a look at us. We've got all of our contact information, and we've got a little bit of information about what we do. And I can tell you right now, they'll get there and they'll, if they want to hit learn more and send an email, they'll end up having an email go to a very nice gentleman named Nathan Darude, and Nathan will end up, Nathan's bulldog. He'll end up giving them a call and talking to them about all kinds of stuff. So we'll get back to them very quickly, and it'll be they'll be able to get a lot of information. But earthoptics.com.
Awesome. Thanks so much for that. And one thing we wrap up each episode with is we ask our guest for one piece of advice to our listeners that are looking at making a soil management decision, just in general. What do you have to offer them?
I think that one thing that's going on with in the entire soil space at this point is understanding and learning as much information as you can about your soil. There has been so much talk about soil health over the last 6-7 years. And I appreciate that. I tend to not use that term because I believe that, we've got to look at our best management practices in soil, and that all starts with the best information and understanding exactly what our crops need and how we have multiple choices to give it to them. And then we know that soil is, finite, and we need to make sure that it is sustainable going forward. So I think that we're right at that precipice of looking at, soil. There's a lot of decisions, a lot of things that are going on at the USDA. And as a farmer today, don't miss the opportunities that the USDA is doing about talking about carbon in the soil. There's a lot of things that are happening in that space. It could be really great economic benefits for farmers to look into that space and see what they can really do. Plus, they can have a feel good of knowing that it's going to help reduce CO2 in the atmosphere.
Thank you very much to Todd Martin for taking the time to join this episode of the FarmBits podcast. It's really exciting to hear how EarthOptics started and how they really fit into this precision agriculture industry. One of my favorite parts of this episode was learning more about how EarthOptics is helping growers practice carbon smart farming and the importance of having more of this soil data available to growers moving forward in that carbon market.
One of my favorite parts of this episode was learning about the precision land management with soil data analysis to help growers and producers on decision making in a sustainable way. I hope you enjoyed this episode, and we are looking forward to sharing another digital ag story with you next week on FarmBits. Thank you for taking the time to join us today on the FarmBits podcast. If you enjoyed this episode, please subscribe to the podcast on Spotify, Apple Podcasts, YouTube, or wherever you listen to podcasts to be informed about the latest content each week.
We welcome your feedback, so if you have comments or questions for us, please reach out to us over email, on Twitter, or in the review section of your favorite podcast platform. Our contact information can be found in the show notes.
We would like to thank Nebraska Extension for their support of this podcast and their commitment to providing high-quality informational material to members of the agricultural community in Nebraska and beyond.
The opinions expressed by the hosts and guests on this podcast are solely their own and do not reflect the views of Nebraska Extension or the University of Nebraska-Lincoln.
We look forward to you joining us next week for another episode of FarmBits.